How are you, friends? Let us today tackle multiplication of matrices. So example, I've got find AB and BA. Here it is my matrix A, though I've not placed the brackets. B, I've not placed the bracket, but there's need of a student, or when dealing with matrices, you place the brackets. Solution AB, the order of AB is 1, 3 and 3, 1. I would like you to note that I've highlighted this one and this one to show that it is possible to multiply them, because the number of columns of the first matrix A equates to the number of rows of the second matrix B. So it is possible to multiply them. So you move on by doing, because it is row by column, so it will be 3 times 2 plus 2 times 1 plus 1 times 3. So of course that is 6 plus 2 plus 3, which will end up to 11. So 11 is a 1 by 1 matrix because it has got 1 row, 1 column. We move on to get now the solution to BA. So the order of BA, that is 3 times 1, 3 rows, 1 column. Of course we are beginning with matrix B today. And then matrix A has got 1, 3. So it means still it is possible to multiply them, because the number of columns in B equals to the number of rows in A. So due to that, when you check at this matrix here, 3, 2, 1 and 2, 1, 3, what we are going to do, we are now taking 2. This is now our row, multiplying with this column. So it will be 2 times 3. Then we are going again to have 2 times 2. Then we are going to have 2 times 1. As you can see, I've done that. 2 times 3, the element at this point. 2 times 2, the element at the second column. 2 times 1, the element at the third column. So we move on again to now 1 times 3, the element of the second row, that is second row, first column. Again 1 times 2, element of the second column, second row, second column. At this 1 times 1, the element of second row, third column. Again, as you can see here, it is 1 times 3, 1 times 2, 1 times 1. We move on again to now multiply 3 times 3, the element of the first column, third row. That is 3 times 3. Then 3 times 2, that's the element of the third row, second column. Then we are moving to 3 times 1, the element of now the third row, third column. Here it is 3 times 3, first element in the first row, first column. Okay, first, that is first row, first column. I mean 3, the third row. We are also having this and this here. At the end of the day, 2 times 3, 6, 2 times 2, 4, 2 times 1, 2, 3 times, and you get such a matrix. We move on to now example 2, whereby we are trying to find AB and BA. With AB and BA, first of all, we have this matrix and this matrix here. These are 3 by 3 and these are 2 by 3 matrix. So solution AB. AB has the order 3 by 3 and 2 by 3. Hence impossible to solve. Why? Because the number of the columns of the first matrix does not equate to the number of rows of the second matrix to be multiplied by or multiplied with. Then we are having solution BA. BA has the order of 2 times 3 and 3 by 3. Of course, I've not placed here 3, but it is supposed to be there. So 3 by 3, whereby we are having 2 by 3 and a 3 by 3. Hence it is possible to solve it. It is possible to solve it because we are having this 3 and this 3. Of course, when we reverse, that is B and A. You can multiply BA, but not AB. Why are we multiplying BA? We are multiplying BA because the number of columns of B equates to the number of rows at A. So when you move there, we are now moving now to see the calculations. Of course, with here, we are now dealing with row by column. So it is 1 times 1, then 4 by 3, then plus negative 2 by 7. So to that extent, we've got the element of the first row, first column. That's the first element. Then we move on to get now 1 times 4 plus 4 times 5 plus negative 2 times 8. We get now the second element that is in the second column, first row. Then we move on to get negative 2 times now, 1 times negative 2, 4 plus 4 times 6 plus negative 2 times 9. With doing that, you are getting now the third element in the first row of the third column. So here it is. I've done it, and I've done it in a distinctive way. Then we move on to get now, now we are having, that is now 3 times 1 plus 5 times 3 plus negative 6 times 7. So with that one, we've got the element of the second row that is in the first column. Then we move on to get now again 3 times 4, 12 plus 5 times 5, then plus negative 6 times 8, whereby after doing that, you'll be getting the second element of the second row that is in the second column. Then we are having 3 times negative 2 plus 5 times 6 plus negative 6 times 9 to obtain now the third element in the third row, in the third column, that is second row. So here it is. And after doing all these summations, you'll end up to negative 1, 8, negative 10, negative 24, negative 11, and negative 30. So after placing your brackets, you'll have such a matrix, and at the end of the day, you'll have grasped the content or the concept of that is multiplying matrices. So ensure, if at all you've not understand, you can stop the video and watch again repeatedly, and also remember to do some more practice in order to understand. Have a nice